Assalamualaikum warahmatullahi wabarakatuh, everyone. My name is Fatin Masura binti Muhammad Sukri, metric number 1242544. For now, I will present the application of differential equation in continuous compound interest. Here is the content for this presentation project. For the first part, let's take a look at Introduction to Differential Equations and Mathematical. So, what are differential equations? Differential equations is a mathematical equations that describe how quantities change over time. Differential equation used in many fields such as engineering, physics, economics, and finance to explain real-world situation. To calculate differential equations for this project, we will use Wolfram, which is known as Mathematical. Mathematical is a powerful software that can solve equations and create visualizations to help us understand how the models perform. In finance field, one basic example of differential equation is continuous compound interest, which can be modeled by first-order differential equation by using Mathematical. Next, we will go through to the example of differential equations problem. A worker deposits 5,000 ringgit into a savings account that earns 5% interest compounded continuously. Find accumulated value after 30 years. First, to solve the problem statement, we need to identify the problem, where in this case, we need to find the accumulated value of money for 5% interest after 30 years. Next, we need to develop differential equation based on the problem given. Third, input equation into Mathematical. Fourth, we need to solve the equation using this solve command in Mathematical software. Fifth, we need to generate graph using plot command, and the last one is to analyze the result. Before we proceed to the calculation, we need to understand what is continuous compound interest. Continuous compound interest is a fundamental concept in financial mathematics, which the current interest calculated from the initial amount sum with accumulated interest of the previous period. This process makes the investment grow faster and leads to the exponential growth, contrary to the simple interest. Under continuous compound interest, we generate first-order differential equation formula, which is dA divided by dt equal to RA, which is A is the principal amount, T is time, and R is the rate of interest. So, here is the computational solution. Based on this line, we need to use this solve formula, and we will get the continuous compound interest equation, which is AT equal to 5,000 multiplied by exponent of 0.05t. Then, we substitute t equal to 30 years and we will get 22,408 ringgit and 40 cents. Next, we need to use the plot command to create data visualization. So, after we plot the graph using the plot command, we will get upward exponential curve graph where the initial investment A0 increased from 5,000 to 22,408 and 40 cents after 30 years at continuous annual interest rate of 5%. This result indicates that the investment grows exponentially and increases rapidly over time as interest continuously earned on both principal and accumulated interest. Based on the result that we obtain, this analysis shows continuous compound interest can be effectively developed using first-order differential equation. By solving the equation in Mathematical, the investment growth function can be obtained, which is AT equal to 5,000 exponent of 0.05t, showing the accumulated amount increased exponentially over time. We also can conclude that Mathematical demonstrated to be an effective tool to solve the differential equation, performs calculation, and visualize investment growth for the financial analysis. Here is the references that used to conduct this project. And that's all. Thank you for watching my video.